let's look at problem 5, longest palindromic substring. This is also a daily challenge problem. So for this video, we are going to provide a dynamic programming solution. So actually, this problem can also be solved using two-pointer sliding window method. But here, let's focusing on dynamic programming method, which is also easy to understand. So first, let's look at the statement. So we are given a string S. So we want to return the longest palindromic substring in S. So here, the return is the longest palindromic substring. But in order to get this one, we need to consider the length of the corresponding palindromic substring. So here are two examples. In first example, BAB is the longest palindromic substring, which has length 3. And in example 2, the double 2 characters form the longest palindromic substring, which has length 2. So about the constraint, so S is not empty and its length can be up to 1000, and S consists of only digits and English letters. So the second one is not that crucial. The first one basically is regarded to the term complexity analysis for a solution. So now let's look at the method we're going to use for this problem. The method is the standard dynamic program method. So for this, we are going to use a two-dimensional table. So this generic element means that so from whether S, the piece, the substring from index I to index J, both inclusive, is a palindrome or not. So if this were a palindrome, its length will be J minus I plus 1. Right, so this is the setup. Now we want to make a recursion relation from this interpretation. So first, let's make several observations. First, a single character is palindrome and its length is 1. And secondly, two same character is palindrome and length is 2. So if two different characters, of course, it's not a palindrome. So thirdly, with that the first two points, we want to update this dpij, right? So in order for this to be a palindrome, we need two things. First is that dpi plus 1 and j minus 1 is palindrome, right? And the character at the two ends are equal, right? Let me change it a little bit. Is 1 if and only if. All right. So this is basically the recursion relation. So let's postpone to analyze the example. Let's go to the code first, and then we can check the special cases. For first, let me make some preparations. So for example, let's track the length of this string, and also we introduce a maximum length variable to track the length of the palindromes. And the result, first let's set it to be empty string, which is what we are going to return. So for the dp table, we are going to do 0 times m for a dummy index in range m. So with that said, so let's do the 3 steps in the observation. First, we will set 1 character and 2 character palindrome. So basically, these are 2 for loop, or just write 1 for loop. Let me write 2 for clarity. For I in range n, let's first set the diagonal element, so dpi. equals 1, meaning that single character at index I of S is palindrome. So its length is 1, and the corresponding result will be CSI. So this is the one for the single character. Now let me check for double character. See, here we write range to n-1 because we need to consider index I and index I plus 1. So here we compare these two. So if Si and Si plus 1 are the same, so basically dp I and I plus 1 will be true. And in this case, the maximum length will be 2, and the result will be Si 2 I plus 1 inclusive. So we write I plus 2 here. So with that said, basically, let's set for generic case. So here, due to the recursion relation, the way or the order to set the values are important, because we need to know dp I plus 1 and j minus 1 a priori before we dp ij, right? So for this purpose, we are going to iterate first for the column index for j in range m, and then for I, so we need I to be strictly smaller than j. Actually, for j minus 1 j, we have already set the value, so we want I in range 0 to j minus 1 here, right? So in this case, so we want to check if dp I plus 1 and j minus 1 is true, right? Or just to check if it's 1 or just left as empty. So we also need to check if Si equals Sj, right? So with these two conditions, basically we can set dpij to be true or to be 1. So we will set dpij in this case to be 1. So now again we compare length. So in this case, the S from index I to index j inclusive are a palindrome. So we consider the length, which is j minus I plus 1. If this is greater than the maximum length, we're going to update the length to be j minus I plus 1. And the result is updated to S from index I to index j. So here we write j plus 1. Now we are ready to return the result. So we are going to return the result. Here, let me check a special case first. So this is for example 1. So actually, in order to see the information, detailed information, we can print the dp, right? So we can print the dp. So we know that from index 1 to index 3, so it's the longest string, which is a palindrome. So from index 1 to index 4, so right, so 4 minus from index 1 up to index 3, right? So the length is 3 minus 1 plus 1, that is 3. So let's look at the second example. So let's do the print again. So we know that from index 1 to index 2, right? So 1, 2 should be a 1 here, right? So that's about the special case. So let's do a final check for generic case. Yeah, in this case, it passes the check. So basically, this solution is O(n) square where n is the length of S. So I guess that's about it for this method to the problem. So we can also look at methods such as two-pointer sliding window in solving this problem. Thank you.